On Tuesday, I issued a challenge to build a data capture system in C#. Hopefully, by this time, you've been able to build that system. If not, take the time to finish up your project before watching this video. Today, I'm going to walk through the process of how I would tackle this challenge. Part of this process will be about knowing what steps to take next, even as I complete the actual challenge. So let's get started building our backend solution. So to start, what we're going to do is create a new project. And this is where you get to choose, how do I want to start? Do I want to start with the business logic? Do I want to start with the data access logic? Do I want to start with the actual database? And my personal preference when I'm dealing with the back end of a system is I prefer to go to the database first. I feel that drives a lot of what you do for your choices. Now, if you want to design the front end, the user interface first, that's fine too, but we don't have a user interface. We're just doing back-end work. And so we're deciding this is the data we want to capture. This is the data we want to not capture and how we want to structure what data we do capture. So I started with a SQL Server database project, and let's call this point of sale. That's the database name, that's fine. And the application we're going to call point of sale app. So we could call this point of sale DB just to be clear here. But this is going to be the point of sale application, and we'll capture or we'll start with the database first. So looking back at our requirements, what we need to do is build a system to capture purchase data from a caller. And we need to store that data in a database. I've chosen SQL Server as the database. And if there's a duplicate user, update the record instead of adding a new record. All right, so it's kind of a vague set of requirements, but we do know we need a few things. So let's actually Control-Shift-A allows us to say tables, and then we'll say, let's just do tables for now. And then we can right-click and say add. I'm not sure, I've never tried it with this to add tables. We can try that in a minute, but we'll say the first, we could say buyer, but let's call this customer. So it's a customer table, and you get to choose, do you want to be singular or plural, customer or customers? It really depends. When you're looking at a query and you say customer.firstname, that kind of makes sense versus customers.firstname doesn't make as much sense, but it's really up to you. So I'm gonna make this an identity. What this does is it says, okay, this ID is going it's going to start at the number 1 and count up or auto increment every time you add a new record. We don't have to mess with this ID at all. This is our primary key. If you are unfamiliar with SQL, I'm going to be doing a new SQL course coming pretty soon. They'll cover more about SQL. I already have a SQL course, but I want to do a new one with some new information. But basically with SQL, you want to have a primary key and you want to choose what it is. And personally, I like the idea of an integer. Some people say, well, when your table gets big enough, you have to have a big integer because an integer isn't large enough. And an integer holds, I believe, 32 million. Might be larger than that, I forget. But that's a lot. And you know what? For most cases, that's enough. Now, yes, when you get into a larger business, then absolutely use a big integer. But this is enough for a lot of cases. And actually, I just looked it up, and no, an integer will hold 2 billion. So if your IDs go past 2 billion, yeah, that's a problem. But I think that int will be just fine for what you're doing here. So we're going to capture, in this case, the customer. So we'll say first name and nvarchar 50 is fine, and we'll not allow nulls. Last name, nvarchar 50, not allow nulls, and then we'll say email. So this is, again, nvarchar. I'm going to say 50 again, and let's talk about this real briefly. So first name and last name, 50 characters is a lot. It's a lot of characters, but it might not be enough for every first name. The question is more a matter of how do you want to design your database? Do you want it to be designed for every possible edge case, or do you want to say this is what we allow? And 50 is our max because that's a lot. Personally, I think that first and last names could probably be bracketed at 50. I think it's enough. Email address, I think the email address can be like 2,000 characters, something like that. But the reality is that's such an edge case as to not really be a problem for, you're not writing a book when you're putting your email address in. And if you are, I'm sorry. So 50 is probably enough. You may want to think about maybe you go to 100, if there's a long domain name and then a long username, but really it's probably 50 is enough. And again, this is a case of edge cases and how many edge cases do you want to cover? There will always be an edge case that you don't cover. So it's a matter of, are you okay with that? And do you have a way to deal with that? So I'm going to leave it at just this for our customer table. You may say, well, Tim, we're capturing purchase data. So where is the purchase information? Well, in my mind, what I'm envisioning is the purchase information will have first name, last name, email address, and what they purchased. And if you go to my website and purchase a course, it's going to pop up and ask you for your first name and last name, your email address, and what you're purchasing, and then, of course, your credit card information. And so as a business owner, I can capture that information. Now, I am very careful what I do with that because I'm under a lot of restrictions as what I can't do that. But we're pretending that this is part of the capture system for something like that. We're going to capture this information in order to do something with it. Maybe we're going to send you an email with a receipt, or maybe we're going to send you a thank you email after 7 days, something like that. So we're going to capture this information in two different places in SQL. And this is where relational databases come in, is we're going to capture it in this database or this table and another table and link the two together. So this is our customer, and we're going to save this table and call it good. And I could put things like, date changed and date added and all the rest. We're not going to worry about it. Next up, let's do the Control-Shift-A and try this out. So we're going to try, this will be the purchase.sql, and it just assumes a blank file. So that's what I was wondering about. So that's okay. We can go ahead and delete that, and we'll say add table, and we'll call this purchase. There we go. And in here again, and this is identity. And now we can say what the purchase is. So we can say item, and let's just call it nvarchar. Nvarchar, there we go. So with 50, and we don't want to allow nulls for that. This is just the name of the thing we purchased. Now, normally we have an ID number for it, and that could be the ID number there. It's up to you. But for this example, we'll probably just say that's the item. Whatever it is, how we're going to identify it, that's where it goes. And you know what? Then we'll put up, let's go with just cost. And then we can do something like money, which this is how much the item costs. And then what we're going to do is kind of link to that customer. So customer ID, this is now a foreign key. We'll call it integer and not allow nulls. This is the foreign key that links back to the primary key of customer. So the way I like to do it is the primary key is always called ID. And then if you're going to link to a primary key, which means you're a foreign key, then you're going to put the name of the table and then say ID afterwards, or what it is, and then ID afterwards. Because sometimes you link twice for two different reasons, like maybe a parent ID, and that could still be going to the customer ID. Let's maybe say parent customer ID, whatever, but it's still linked to the customer table. But if you're just having a one link thing, then customer ID really works well because it makes it very clear where is that link to. Okay, so that's what we've got set up. We could set up, our indexes and our foreign keys and all the rest. I'm not going to do that here. We're trying to keep this as clean as possible, as quick as possible, because we're already 10 minutes in and just got the database going. So let's call this good. And next up, what I'm going to do is I'm going to create stored procedures. Nope. You have a trailing slash. There we go. And then in here, let's create some stored procedures. And we're just going to be doing writing to this database. We're not going to be doing any reads to the database. So we'll say SP customer insert. Actually, let's call this an upsert. So what we're going to do is an upsert is a term for either an insert or an update, depending on the data. So what this will do is it will take in some parameters. So we're going to start with the first name, which is nvarchar50, last name nvarchar50, and then email, which is nvarchar50. And then what we'll do is we will allow the system to figure out, do we need to insert the data or update it? Okay, so in here, this is kind of like my structure for the for a store procedure. So you start off with a name, then you have any parameters you're passing in, and let's actually have one more that is at the beginning here. We're going to call this just ID. Well, let's call it customer ID, and that's a output. Okay, so this is going to go the opposite direction. When we do the insert, we'll return the newly created ID. When we do the update, we'll return the ID of the record we found. So that's how we're going to do our structure of our data coming in and going out. All right, so let's start with a check to see if it exists. If exists, and we'll do a select one from customer where customer, and that's customer ID is not correct. We're going to say where email equals email. All right, so we're checking to see if the email is in this customer table. Now, let's talk briefly about this. We are looking up and saying each email address is unique per purchase. And this is something to be careful of because you don't want me to see your primary key. For sure, do not do that. The reason why is because email addresses change. And not only that, you might have a case where two people share the same email address. Now, in our case, what we're saying is if you share the same email address, you share the same account in our system. That seems to make logical sense. But, your email address might change. You might, maybe it's a Gmail account. You decide to, change the name for whatever reason, whatever it may be. You don't want to say that's your primary key, but you can link your purchases to that email address and say, well, if you change your email address, we can always change the customer record to point to the new email address. So that is just something to think through. We're going to say, we're going to look up based upon, this is trying to guess what I want here, and it's not right, but we'll start with it, and we'll say begin, end, and inside here, what we're going to do is say update. So if it exists, we're going to update the customer, and we will set the first name equals the first name, the last name equals last name, where the email address equals the email address. All right, so that's going to be the first thing we do in here, and then we're going to select the customer ID equals the ID from customer where email address equals email. So what we're doing is grabbing the ID from the customer table where we have an email match, and we're putting that into our customer ID. So by doing select customer ID equals, it's going to assign the value of the ID into our customer ID, which is an output value. And that takes care of our our if exists. Now, there's also the case where it might not exist. Else. I would say begin. So in SQL, make sure you have a begin and an end. I like to have begin and end everywhere, even though you don't technically have to if you have just one statement. It's only if you have multiple statements you have to have it. But I just think it's much cleaner to have it because that way you don't have any problems with scoping issues. Okay, so we didn't find it in this case. Well, insert into customer, and we'll say first name, last name, and email address. Values, and their first name, last name, and email address. Boy, the GitHub Copilot's really helped me out here, and it's writing some stuff for me. So you got that first set done. Notice I'm putting semicolons at the end of every SQL call. That's not strictly necessary, but you should do it. It's clean to do it that way. And then we just say select at customer ID equals scope identity. This is important to know how to do because of the fact that what it's going to do is grab the latest ID from the current scope. What's a scope? Well, it's a transaction. And if you didn't know, store procedures have their own transaction. So the transaction begins at the begin, it ends at the end. Everything inside here, which the last thing we did was insert this record. Therefore, we're guaranteed to get the right ID here. If you recall this in C# and call this first and then call this, you're not guaranteed that this call right here is the last insert, especially not in a busy database, which means you can get an ID number that's wrong here. It might be off by only a value or two. It might be 5 instead of the 4 you need. Well, that could cause a serious problem in your database. So doing it inside of a scope is really important when you're doing this. Okay, so that's all we have to do for our store procedure for inserting or for upserting our customer, at least until we test it and see that it doesn't work for some reason. But that should be fine. And then we're going to create a new store procedure that will be SP purchase. And this will be the insert. We're always going to do an insert for a purchase because of the fact that there's no upserting, there's no overwriting a purchase. And a purchase is a item, cost, and customer ID. So item, cost, and customer ID. And we'll have the customer ID because this store procedure returns the customer ID. So then what we'll do is say begin, end, and inside here, we will say insert into our purchase and the values. I don't know why it always tabs in one, but that's fine. I can do the tabbing if it does it right in the code. So we're going to insert into the purchase table the item, cost, and customer ID, and then the values at item, at cost, and at customer ID. So basically just passing this information in and we're done. Super simple store procedure. Okay, so that's our code essentially. That's our T-SQL for creating our database. We have 2 tables and 2 stored procedures. Now what we need to do is right click and say publish on our project. And we'll say edit here. And we're going to do, let's do browse. I think it's local. There you go. The MS local DB, it's probably what you have. You might have another one, but MS local DB is fine. Hit OK. And I'm using integrated security. That creates this target database connection. And I can give this database a name. We're going to call it same thing as our project name. So point of sale DB. But I'm not going to hit publish. I'm going to say save profile as and save this right in my project. So I hit save here, and that creates this XML file right here. If I double click this, it's going to open up that same dialog with everything filled in. Then I hit publish. And it says, So a project which specifies SQL Server 2022 or Azure SQL Database Managed Instance as the target platform cannot be published as SQL Server 2016. So my local DB is, if we look at SQL Server Object Explorer over here, my local DB is, well, it's not coming up. Awesome. I think we locked up a system. Interesting. Just a minute. All right, I think that's better now. There we go, much better. So I had to restart Visual Studio. But in the SQL Server, I have this local MS Local DB, which is a local database. And if we right-click on it and go to Properties, it's going to open up here and tell us a little bit about it. And if we dig in here, we find out that it's a SQL Server 2016 is what it's imitating. So you can see here right now, SQL Server version is 13.0.4001. So with that, it's not a as modern of a SQL version as we might expect from a later version. And if we kind of open this up here, we'll see down below it says the SQL Server Express is what it actually is. So not a problem though. What we need to do is the error message told us what to do, and that's something that you need to pay attention to is error messages. Don't just freak out and say, oh no, I have an error message. Actually look at what the error message says. Let's go to, I believe it's under Properties, Target Platform. There you go. Done. So analyzing database schema, it'll be ready after 78 operations. That's pretty impressive though. It's that fast for 78 operations. But now we can double click this again, load it. This is why I saved it beforehand, so you can do this over and over. Hit publish, and it's going to publish to my local DB. So that's what you might need to do when you're publishing your database. Don't panic, don't freak out. Just change the target version. That does mean that right now you might not be able to use some of the latest stuff since I'm targeting an older version of SQL Server, which might be something you have to do as well. And that's okay. You just, whatever you can use, you use. And if you can use the latest stuff, cool, go for it. So now if I come over here and we look at databases, one of the databases is going to be called Point of Sale DB. If you open this up, we have two tables, customer and purchase. We have under store procedures, we have two, customer upsert and purchase insert. All right, so we're all set on the database side in theory. Let's close out all tabs here. And now what I want to do is I want to kind of work up. So I want to create now a class library. So new project. And then in here, we're going to create a class library. Wait for it. Let's change this back to all project types and C#. But then over here on the left, I have class library. And we'll call this Point of Sale Library. And .NET 7. You can use whatever version of .NET works for you. I delete class 1. That's the easiest way to clean things up. Make sure you don't have anything weird hanging out there with that class 1 file. And then I right click on it and let's say, actually, you know what? Control-Shift-A. I really prefer this method. I just forget to do it. My right click is always, ingrained in my brain from years and years. But Control-Shift-A with this new dialog is great. So what I want to do is create, let's create the data access for this and also the models. Let's start with models. So we'll call it models, and then we'll say customer. Okay, so there's our customer model, and then what we'll do is we will put our semicolon here, make a file scope namespace. We'll clean up the usings and sort. We'll make this public. And then what we're going to do is match what we have in the customer table, which we do have an ID of that's an int, but then we have a string first name, and we have a string last name. So that's our customer record. We also have an email address. So let's put that in there as well. All right. And then we have a set of purchases. So let's go ahead and actually, let's not. Because we only have an insert. We don't have the reading out from the database. So let's call this customer purchase. Hit a control dot to rename the file to customer purchase. There we go. And so you have our first name, last name, email address, and we're also going to capture the purchase information because this is going to come in from an API. So they're going to pass us all this information at once. We're going to assume that each purchase is only one item. That's up to you if you want to do it that way or a different way. We're going to say it's only one item. So item and cost. That's the things you want to capture. So string item, and this is going to take decimal for cost. And then we should probably call this the customer ID. Actually, you know what? We're not even going to capture this because the user won't know. So first name, last name, email address, item, and cost. That's going to be a customer purchase, and we should call it customer purchase model. Make sure you rename the file. Okay, so we have our customer purchase model, but now we need to create our data access. So let's go back to our project and Control-Shift-A, and we're going to say, let's call it the data folder, and then SQL data access. So that's our SQL data access. We'll do the cleanup on this as well. So we'll remove and sort our usings, make this public. And what we're going to do here is we need to do some data access to talk to SQL. And it's just really, we just need an insert record here. So let's start by adding our dependencies. So we'll add a NuGet package for Dapper. I prefer Dapper for my data access. This is the correct Dapper. It comes from the team who created Stack Overflow. So it can connect to pretty much any type of relational database. So SQL Server, MySQL, SQLite, SQL CE, Firebird, and so many more things. We're going to insert that. Along with this, let's add the system.data.sql client. So we'll add this and install it. And accept. All right. And then we will also install the, I believe it's Microsoft.extensions.configuration. It's configuration or configuration.binder. I believe it's binder. So let's install binder, make sure that's the right one. But yes, it's binder because it not only installs that, but also installs abstractions. Okay, so that should be what we need in order to talk to our data access. So let's, there's our new stuff. But let's now start creating our configuration. So I'll start with a constructor where we say, you know what? I need iConfiguration. Control dot to add that namespace. If I spell it right. There we go, iConfiguration. And now control dot will add the namespace correctly. And we can say config, control dot to create and assign a field. And then in here, we need a method. And so our method is going to be public. Well, we're going to return, no, we're just going to insert data, right? And we're going to be pretty specific about this. We're calling this SQL data access, but really what this is data access for, well, okay, let's talk through some structure here. We could create this as a generic insert statement. I think we will do that. And then wrap another class around this that calls this and does a specific work for inserting customers specifically. I think that's where we're going to go. And so we're going to say is public void save data. And it's already saying, hey, do you want to do this? And let's just hit tab and see what it creates for us. So let's unpin this here. And what this is saying is using var connection. Okay, so we're going to create a connection, and I prefer to, well, I usually say connection, but we'll see. We have to control dot here in the new SQL connection using system.data SQL client. And what we're going to do is create a new connection to SQL Server, and we're going to get the connection string called default. Now, we could specify which connection string in here, and that'd probably be a little bit more, more reusable. And so I think we're going to do that. We're going to say string connection string name equals default. So we'll have a default value for this that is default. We pass that in instead. That way, this is a little more flexible when you call it, so you can call it with a different connection string than just the name default. Okay, so now we have the connection.execute, which we have to add the using for Dapper for this. So now we have 3 using directives up here. And we have execute, which is just going to, actually want to execute this asynchronously. So let's do execute async, which means this is no longer a void, it's a task. All right, so we're going to, actually you don't have to make it a task, we can make it a void. So when you execute async, you could await it. But the question is why? Why are you awaiting this here? Because you're not actually doing anything. Or what you can do is say, no, this is a task, which allows you to then say return, and this execute async, which returns a task. So you could do it that way as well. But what we're doing here is saying that we want it to be asynchronous, not synchronous. You want to talk to databases asynchronously if at all possible. Okay, and we do want to say the command type here is store procedure. So we'll specify that. That way it's going to execute as a store procedure. We're passing in not just our SQL, but our procedure. So we'll rename that. There we go. And we can put this on a couple lines here. In fact, we can do quick actions refactoring and wrap all the arguments like so. So there we go. We now have a save data that's a generic save data. So we can pass in whatever data you want, and we'll execute this. The data we're going to pass in, though, I think we need to modify. And this, I think what we're going to do is instead of T, we're going to say we want dynamic parameters. So that way, and again, let's use our quick actions refactoring to wrap every parameter. There we go. So they'll have to know about dynamic parameters and how they work. They come from Dapper. So the caller has to know that, but the caller is going to be in the same class. And the reason we want to use dynamic parameters is because you want to have that output. So we want to do the parameter direction of output for our customer ID. Okay, so with that set up, I think we have our insert or our save data set up properly. Now, if we wanted to be complete, we also create our load data, but I think that this is what we need, and so that's all we're going to do. Now, next up, what we're going to do is we're going to create a new class in here. And we'll call this something like customer data class. So it's customer data, not customer data model, customer data. And we'll remove the usings. We'll make this a file scope namespace. We'll make this public. And in here, what we will do is we'll have a dependency on the SQL data access. Now, one of the things that I do, and I hit Control dot here and extract an interface, and it extracts a new file. I hit OK, and now it's an iSQL data access. And the question comes up, why do you do that? Because we can just call it SQL data access. But what this does is a couple of things. One, it allows us to work against an interface, which means we can change out the implementation later without disrupting the actual application. We can just change the dependency or the thing that it depends on. And that's through dependency injection. But the other thing is this makes it very easy to test because we're passing in interfaces, which means we can create our own version of the implementation for our unit tests in order to give back, results that we can expect and not yet touch the database. So it's not an integration test. It can still be a true unit test. So that's why we use interfaces. That's why I use interfaces. That makes life a lot easier. So now in here, we can say constructor, and we'll ask for a iSQL data access, and we'll call this just SQL. Control dot to create and assign a field to it. And now we can create a method. Let's create a method called public, and we'll say it is asynchronous, so task, and I'm not sure we want to return any values. We're just going to say insert purchase. All right, and we're going to take in a customer, wow, spell it right, Tim. Customer purchase model. There we go. And we'll call this data. Okay, so we're going to insert a purchase. We're going to pass in the customer purchase model. And what we need to do first is create that dynamic parameter. So we'll say, let's call it dynamic parameters. And we'll say P equals new, like so. Notice that up here, add the using for Dapper, as well as for the models. So now we have as dynamic parameters, we can start adding to it. So first name and last name, and it's not putting the @ symbol in front. We'll take care of that in a minute. And well, we don't want item yet. We want just a first name, last name, an email address, and then, or an email. And then what we want to do is we also want to have one more that is p.add, and I believe it's called add customer ID. And this one is a bit different. We were going to say that the DB type is going to be DB type dot int32, and then the direction is going to be output. Now I'm going to take these off here. We don't have to have system.data here or here, because we're going to say control, whoops, not control comma, control dot, and add the using directive. There we go. And what we've got now is an output value. So we have this customer ID. So this particular entry, we're going to insert it into the customer table. We have first name, last name, email address, and return that customer ID. And that's because of the stored procedure, which let's pull that up here real quick. That's why it's nice to have your project in here as well. So we have our customer ID, which is an output, first name, last name, and email address. That's the first call we're going to make. So now we can say is await, which marks our class as our method as asynchronous, which is great. Await SQL dot save data. And it's not called save data async, it's called save data. We might want to change that. But I also don't know that we need, let's go back to our save data here. Are we actually using the T anywhere? We are not. I don't see the use of the T anywhere. I'm not sure why. If we were using the generic, we'd keep it, but normally I use the generic and normally I'm passing in a default here, but we took that out. So that means also we change the interface so that It doesn't rely on the T either. So we're going to do save data. And the first thing I'll pass in is our DBO dot, notice it says store procedure name here. So DBO dot SP, and this is customer upsert. And then our data is P. We'll leave the connection string at default. That's fine. And once this call has been made, then what we'll do is we're going to grab the information from the integer. So we're going to say int customer ID equals p.get. And we'll say it's an integer. And we're going to ask for the at customer ID value. This will get us back the ID that was passed through the output. All right. So now we have that, we can create a new call. So P equals new. We're going to renew that and start over. And this time we're going to say p.add, and we'll pass in first the, let's start with the item, cost, and customer ID. Okay, so we'll do the same order, item. And the item is going to be the data.item. And then p.add the cost is data.cost. And then p.add is going to be the at customer ID. And this is customer ID we just got from the first call. So you have that new value. We're going to await, save a data. We're going to insert into the, this is not quite right, but I will tab through and call it. This is going to be the customer or the purchase insert. Not customer purchase, just customer or purchase insert. So this is the purchase insert store procedure. And that's going to insert the values. Once that's done, we're done with this call. So in theory, we have all the code written to write this method, or to make this method work. So if we look at our requirements said that we need to store the data in a database. We're doing that. And if it's a duplicate user, update the record instead of adding a new record, which is what we're doing. We're updating the customer with, or the customer with more purchase data. So that's what we're doing. Now what we need to do is have some way to capture this. Now we could call this good, and I could write a unit test that tests this, do some integration tests as well. Or we can do is right-click on the solution and say add new project, and let's create an API project. So we'll call this point of sale API. I could also do an Azure function. That would also work, but an API is what I'm going to choose. We're going to use the minimal API. I'll hit create. And then I'm going to set this as a startup project. And I'm also going to go to dependencies and say add project reference and reference the library. Not both directions, just the API talks to the library. Okay, so now we have the API talking to the library. Now what we need to do is come in here into our app settings and set up our connection strings. And in here, the way I like to do this is to leave it like this. And then I right-click on my project and I say manage user secrets, and that opens a separate secrets.json file. This is not in source control. It's only on my machine, which means if I copy this and paste this in here, this version will overwrite app settings. And if you don't know how that works, I got a whole course on app settings that's pretty cheap that covers all of that. But in here, what I need is a connection string. That way I won't disrupt anybody else with my test connection string. And at the same time, I wouldn't give anything away if there's any kind of secret information as well. So I'm going to come over here and select the database. So I got the point of sale database. If I come over to properties, and its whole property list. And in here is going to be the connection string right here. I'll put out a little more. Connection string. If you double click, actually Control A when you're selected in here, select the entire thing inside a connection string, copy it. In secrets.json, paste it in. That is the connection string for that database locally. Now, this is integrated security is true, which means there's no username and password. Sorry, it's scrolling on me here. Integrated security is true right there. So what that means is it uses your login from Windows, does not know your password from Windows. It just says, hey, if you're logged into Windows, then you should have, you should be able to access this database. And since the local DB has pretty much no security on it, that's cool. It works. So with that, our secrets.json is updated with our connection string for default, which means that when we ask for, or we pass in and say, hey, the default connection string, we're good to go. Next up in program.cs, we come here to our services, and we're going to say builder.services.add. We can add a singleton. There's no reason why we need to have more than a singleton because we're not storing any data in our SQL data access, and that's going to add the using directive. And we want the SQL data access as our implementation. So now we can ask for that. And we also want one more. Builder. And we don't have, I don't think it's called product data, is it? It's called customer data. Which let's hold off. We'll say services, but I'm going to hold off and do any more. Come over to customer data, and let's create the same interface type structure for this. Extract an interface, hit OK. You've got an interface now called iCustomerData, and that's right here. Let's actually just make this file scope namespace and also copy the name here. Because now we can say, again, add singleton with iCustomerData and customer data. So we have to add both of these because the customer data is going to ask for, so customer data asks for SQL data access data. So we have to have both of these in dependency injection, which means we're declaring right up front, these are the things we depend on. Now, coming down here, well, we got some standard stuff from Microsoft. We can get rid of this. Let's hack it out. Get rid of this. I like to leave something here just to see, what the pattern is here, which can be fine. If you don't want to do a pattern here, that's fine. But app.map post, we're going to do a post here, and we'll say that this is purchase. So we'll call it. And from there, let's start with nothing being passed in. We do need something passed in, so we'll set that up once we finish the structure of this. Okay, so there's a structure of this we have for our post. Now we can do is pass in some data. I'm going to pass in the model customer purchase model. Now, what you might want to do is have in your API a model, a similar model, but a model that is for your API. It's up to you. But I'm going to pass that in. It's going to add the using directive for that once let's say data. Nope, it's not going to add it. So I have to hit Control dot and add the using directive there. There we go. Now it has the using directive. And now with this, what we can do is we can pass in this data through the purchase endpoint and then do something with it. Well, we also need to have the iCustomer data. So let's ask for that as well. And we'll say, let's say DB for database. So we have our database, we have our data. So we can say DB dot insert purchase data. And guess what? That's done. So now you can get rid of this internal record here. And we could leave this as it is. Now let's make sure we test this, because who knows, we have not done any work on this to make sure that, you know, we haven't tested it along the way. I really like to test it along the way, but I've been trying to get through this and kind of get all the pieces in place. And no, I haven't built this before. This is the first time building it. Yeah, why not on screen, right? So purchase, try it out. So we have our first name, Tim. We have our last name, Corey. We have our email, test@test.com. We have our item, and that is, you know, maybe an ID like SA-123-01, and the cost is $55.42. And we hit, I'm going to copy this just so I have it in my buffer here, execute. And the response is a 200, which is amazing. So that's saying we were successful. Let's see if we're actually successful. So let's close this out. We'll go to SQL Server Object Explorer. We'll come down here to customer, and we're going to say view data. And we have nothing in here for customer. Excellent. And if you come over here to purchase, and we right click and we say view data, we have nothing in here either. So let's figure out why not. This is part of the development process. We're going to debug. We're going to start right at the top. Oh, you know what? I know why. This is important to do. Let's try this again. And this time I'm going to await this call. And what it says is, hey, you need to mark this as async. So it marks it as async right here. We need to await the insert call. We can't just make the call. This is why a lot of times you call this async at the end. And I probably should have. That's something we can rename. In fact, let's go to F12 here. And we're going to mark this as async and control dot to rename this. But then we have to go to customer data and also, it marked it as async. Awesome. That's even more brilliant than I thought it was. So it has renamed this async. That way we know this is an async call. Now we should probably also go over to our SQL data access and mark this as async as well. Let's rename it. There we go. So that should be the solution we need. So I'm going to leave off the breakpoint for a minute, and we're going to run this again. That's why I saved this. It's experience talking, right? So I paste this back in, I hit execute, and we get a 500 error. And we look at why trust server certificate, keyword not supported. Okay. So it did not like it looks like the connection string. So it didn't like trust server certificate in the connection string. All right. That may be something they've changed because that used to work. No worries though. What we can do is come down to our, do I still open secrets.json? Yes. So I have our data source, I have catalog, and then we have integrated security equals true. Right here, this trust server certificate equals false. So I know for a fact we don't need anything past integrated security equals true. So take it out. Try it again. And again, this is why you save that data so you don't have to retype it over and over and over again as you go. So try it out, paste it in, execute it. We get a 500 error. Task was canceled. All right. So in the SQL mapper, which came from customer data.cs line 24, the task was canceled. All right. So what we can do is we can come down here to SQL data access line 24 right here. And this was canceled for some reason. So what I'm going to do is I'm going to await this. All right. And we can hit stop here. I'm going to await this call. And this should be an async method, like so. What this will do is, yes, it's going to wait for it, even though you're not actually doing anything with the return, but this should solve that problem. This is where this testing process comes in. I like doing these things live like this because this is how you actually build something out. As you figure out, oh, I made that mistake there. I've made it before. I should learn how to do that again. This time it says 200, which is successful. But we've already seen that you can get a success when it's not. So let's view the data. And this time we have data in here. Very cool. So we have data for that first table, and let's view data on a second table. And notice the customer ID is in here as well. Now, what we do is we test it a few more times. So the first thing I'm going to do, I'm going to run this again, try it out, paste it in again. This time I'm going to change this to Sue Storm. I have to change the email address as well. Otherwise, it would be the same thing. And let's mark this as 125, and the purchase value is 1065. And hit execute. And it says 200 successful. I'm going to not go to our database yet. I'm going to paste over this the original value again. This time I'm going to say that this also is 125 and it's 1065, I believe, which remember, it's going to match up the email address in theory and say that that goes with my record. So let's execute again. And again, we get success. Now we can close this out and we can refresh this. Oops, refresh. There we go. So now we have 3 purchases. And notice that for this purchase, it's customer ID 1. For this purchase, it's customer ID 2. For this final purchase, it's customer ID 1. And if we look at the data for this table, we'll notice we only have 2 records, first name and last name, Tim Corey and Sue Storm. We don't have 3 records because that third record points back to that third purchase points back to the same customer as this one. So we have now successfully created a backend application that handles all of these scenarios that we need it to. Now, with this, there's a lot more to do. Now, I have technically accomplished the mission, so we're going to kind of end it there, but I want to talk through what's next for this because you need to know that almost no application is ever finished. In fact, if you call your application finished and it's anything more than a super minor application, you're probably wrong. And here's why. This is not one of those it depends scenarios almost in any way, because there's more checks to be done. There's more efficiencies to be added. There's more ways to make this even better. Now, this is a pretty well-structured application that can probably grow pretty well from where it is to an even bigger application without a whole lot of redesign and restructuring. But what it's not is, first of all, it's not over-engineered. We did not throw a ton of design patterns at this. We threw some, but not a lot. We did not focus in on making sure we had total separation of everything. For example, in our program.cs, the API, we have our post. Well, we only have one post. I mean, like, it's not a big deal. You have, it's four lines of code, really 2 lines of code and just curly braces, but it's 4 lines in our program.cs. That's totally fine. But as we grow, we want to extract that out and put it somewhere else. We also don't have error checking in here. That's something we need to add with better return value messages. So instead of giving the actual code value, or instead of just saying random 500 messages, we want to be more descriptive of what's going on. Maybe the database can't be found. That's an error message we return separately from something like bad data. Like, for example, maybe the customer didn't give us all the information they needed to in order for us to actually insert this data. So we need to make sure we validate that. We also need to log this to make sure we have, track of what happens when an application is running in production and something goes wrong. We need to have kind of the step-by-step process for that. That's another thing we need to add to the system. We also have not documented this system. Documentation is super important, and it's something we should add. We haven't deployed this system, and it's something that we need to do as well, because we need to set up a continuous integration and deployment for our dev environment, and then for at least production, if not a staging or a testing environment as well. So that's something else to think through. There's a lot more to go. There's a lot more just as a simple application. But right now what we have is an application that captures purchase data from a caller. It stores it in the database, and if there's a duplicate, it updates the data instead of inserting a new record for a new customer. So it does all the things we asked it to do, but we've still got a long way to go when it comes to making sure this application is really solid for a good back-end application. All right, so we have our structure, we have our class library, we have our database, we have our API. It's all set up. I'd also be adding unit tests in here. I'd be testing to make sure this thing works the way we expect it to. Some integration tests to make sure that the process flows correctly all the way through, so that we can have confidence in this system, and we make changes to it. We have confidence that the changes we make are something that aren't going to destroy the system, but instead accomplish what they need to without having adverse effects. So lots more to do, but that's a good start. And my question to you is, did you get this far? Did you have something working like this? Did you choose to do a different entry point? Did you maybe just use your class library, or did you use Azure Functions or something else for your entry point into your backend application? I'd love to know down in the comments. You can't link in the comments. You can't put a link to your GitHub or something like that. YouTube is pretty strict on not allowing links. And quite frankly, I'm not going to turn on, or try and bypass that, because of the fact that that's where a lot of spam comes from. So, but you can talk about it and say, hey, this is what I did and how it works. And, this is where I struggled, or this is where I did something a little different and found success there. All right. Thanks for watching. Thanks for being a part of this particular challenge. We've got another challenge coming up next week. All right. Until then, thanks for watching. And as always, I am Tim Corey.